Hi everyone, this is Ms. S from Excelsior Charter School, and we're doing Geometry, Lesson 8-2 on special right triangles today. These are some of the vocabulary and important ideas we're going to be covering, which belong in your notes. So to begin with, some review of a right triangle. Remember, in order for something to be a right triangle, it has to have a 90-degree angle. And once we've established that, remember that the side across from that right angle is always known as the hypotenuse, and the two sides that make the right angle and form an L are both the legs. As we progress in geometry, that is going to be very important. So now to remind you about Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is always equal to the square of the length of the hypotenuse. A squared plus B squared will equal C squared in this scenario. Remember that you can always utilize this formula when you are trying to solve for the lengths of a right triangle. However, there are some special circumstances that we're going to cover today. The first is called a 45-45-90 triangle. And so we have, once again, our right triangle here in yellow. And in a 45-45-90 triangle, we have our right angle, and then the other two angles of the triangle are congruent. They're both 45 degrees, which makes this an isosceles triangle. If the legs are whatever value, we can call those x, in this isosceles right triangle, then whatever the leg is, if you multiply that by radical 2, you will always get the length of the hypotenuse. So radical 2 times the length of a leg will give you the hypotenuse. And if they've given you the hypotenuse and you need to solve for the leg, it's the hypotenuse divided by radical 2. Our last special triangle is called a 30-60-90 triangle. So once again, we have a 90-degree angle, and then we have a 30-degree angle, and the other angle would be a 60-degree angle. This one is a little bit more complicated than the 45-45-90 triangle because this is not an isosceles triangle. So if we begin with the short leg, and we call that x, the hypotenuse will always be twice that. So 2 times the short leg will always get you the hypotenuse. And for the long leg over here, it's always the short leg times radical 3, so x times radical 3. Again, Pythagorean theorem will also work for these, but the special triangles are kind of a shortcut way to answer these. So let's go ahead and do one of the problems from your homework. We need to solve for each of these variables, and notice we have 2 right triangles here. The one I've highlighted here in red is a 45-45-90 triangle, and the one on the left in yellow is a 30-60-90 triangle. Let's go ahead and deal with the 45-45-90 triangle first in red. So if we remember that this 45-45-90 triangle is an isosceles right triangle, we know that the one across from the right angle is the hypotenuse, which makes each of the other two a congruent leg. So if this leg is 5, this leg must also be 5. And now we have our first variable. Because of our special triangles, we know that there is a relationship in a 45-45-90 triangle between the leg and the hypotenuse. And that relationship is that whatever the leg happens to be, in this case it's 5, you multiply that by radical 2 and you'll have your hypotenuse. So we know that y is 5 radical 2. And we're finished with the 45-45-90 triangle, and we'll move on to the 30-60-90. Remember here in the yellow that opposite from the right angle is always the hypotenuse. Opposite the 30-degree angle is always the shortest side, and opposite the 60-degree angle is the longest leg. The only side we know now is that x equals 5, and it's across from the 60-degree angle, which means that's the longest leg. And since they've given us the longest leg, that will make finding the other two lengths here the most challenging in this scenario. So it is important to remember that the longest leg, in this case 5, is always the shortest leg, in this case z, times the square root of 3. And in order to solve for z, we'd have to do the opposite of multiplying by radical 3, so we'll divide by radical 3. And 5 over radical 3 would be the answer, except we can't use radicals in denominators. It's against the rules. And in order to remove a radical from a denominator, you have to do a process known as rationalizing the denominator, which is when you multiply the top and the bottom of a fraction by the denominator, by that radical 3. And I'm working backwards here, but I think you can still figure out where I'm going. So on the top, a 5 times a radical 3, the 5 is on the outside, the 3 is on the inside, and it will remain so since 3 is not a perfect square. On the bottom, a radical 3 times a radical 3 is a radical 9, which is a perfect square, and the square root of 9 is 3. So on the bottom, we actually have 3. And since a 5 and a 3 on the top and the bottom can't be reduced, and because the 3 on the bottom is on the outside and the 3 on the top is on the inside, it can't be reduced either. So the answer for letter Z is 5 radical 3 over 3. And to solve for letter W, remember in a 30, 60, 90 triangle, W is the hypotenuse here, and the hypotenuse is always the smallest side, in this case, 5 radical 3 over 3, times 2, which gives us 10 radical 3 over 3. And since none of this can be reduced, that's the answer for W. Good luck, everybody. I hope you guys all do great.